And then the power factor, again, as mentioned before, measures the energy component of a charging current, typically the level of quality. Okay? So the power factor installation test equipment, and SRP conducts this at my site on a regular basis to determine what is the resistance from within my facility. Okay, as I mentioned before, as I got power coming in, I always extract power going back out to the substation. So it goes through every circuit, every piece of equipment, and goes right back out into their main lines. If it drops and I don't have that power factor to the level that I can put it back into the grid, then what happens, they have to provide additional current and amperage into my facility, right, to push it back out. So when it gets to a certain level, then I can be penalized or fined for that. So in some cases, I want to make absolutely sure I keep track of what my power factor is going to be at my facility. Typically 92 to 95% in regards to power factor. But extremely important, because what that's telling me is what my rest of my facility is doing, okay, when it comes to that point. Okay. Motion analysis of circuit breakers. Okay. Motion analysis is, do they actually operate and trip? Okay. I mean, does it take effort to actually trip it? And how much effort? I mean, you can actually measure that in regards to pounds. Okay. And then insulation and insulator materials provide and maintain a high resistance to the flow of electricity. Okay. And that's what they're there for. It's an insulator. So when you touch the breaker, you don't want to feel the current, right, that's running through that breaker. That's what it's designed for. It's a safe operation on how to disengage and de-energize, okay, your systems in a piece of equipment. And every panel, as we mentioned before, is going to have a panel schedule. That panel schedule identifies your circuits. So part of your construction commissioning activities are turning over all your panel schedules. All the circuitry, what it's feeding, okay, both from your source, being a panel upstream, versus to that particular lighting system, piece of equipment, okay, air handler. Extremely important. Emergencies, there's one segment we cover emergency preparedness in facilities maintenance. Exactly that. If I have an outage, I need to know which circuit was compromised and which pieces of equipment are actually supported by this particular circuit. It's going to give me an indication on load and where I need to start in regards to my evaluation. Okay. Insulating types of liquids provide cooling and insulating properties. Believe it or not, it's not only type of materials, but in some cases you're going to have liquids and gases. Okay. Typically found in circuit breakers. Remember I asked the gentleman with the older central plant, are your circuit breakers air-cooled or liquid-cooled? He mentioned they're air-cooled. In those cases, you could see the vents from behind those circuit breakers and the panel boards. Okay. Typically mineral oil for outdoor use. Okay. And in some cases, the corrosive environments, okay, that these are going to be subjected to. Specialty testing services, again, certain companies, Emerson would be one that provides the testing. Other entities would be PS&C is another. They're a national contractor that provides the testing for your breakers, primarily for transfer switches on data centers. Check for contamination, overheating, okay, sludging, chemical changes from within the different types of liquid medium and gas mediums. Okay, not only in breakers but your transformers as well. And then the same, it's going to require regular maintenance and testing. So your ports, which way do they face? Okay, in a transformer, do they face against a chain link fence? I can't get to it. Or do they face towards the pad where I can easily take, a sample of that particular one? Accessibility. Did I pour a concrete curb around a transformer where I can't access it, or a block wall? And cooling. I have enough distance between the block wall and the transformer. Typically all spelled out in your specifications during your construction. But when you see it and you ask yourself, gosh, not just got to finish my pad for my transformer, put my block wall up. It's a screen wall, obviously, for the city. But now the next question is, is it going to be maintainable? So I have to remove the transformer to replace it. Okay, how much infrastructure do I have to dismantle? Do I have to tear down the block wall with rebar in it every time I have to switch out a transformer or perform maintenance or service on it? Okay, and switchgear maintenance, the same. Again, moisture, dust, heat, attributes that attack your systems. So in Arizona, very dusty. Okay, extremely dusty. That's why I always, when I look through central plants or any type of electrical vault, typically you won't see a high level of contaminated dust. I call that housekeeping. Okay, regular maintenance on that. But if I have a system that has open to the outside, or I put a large vent with no filter system on it, okay, that's going to impact what the level of quality in time. Won't happen overnight, but over several years of use, definitely so. Okay, as I mentioned before, regular exercise and inspections, visual and systems testing and inspection, heat degradation, arcing. Believe it or not, a lot of folks think, well, arcing is part of power. Well, in some cases it may be. But when you get excessive arcing across the breakers or across two poles, that's going to start to degrade what the metal and also the materials and also your quality and reliability of that particular component. Filtrations, filters, in regards to, you're going to have some sort of filter system for a lot of your intakes for your electrical components. Those require maintenance, believe it or not. Removing those and changing them, cleaning them, regular inspections. What you don't want is you don't want the inside of the cabinet contaminated with dirt and dust. Okay, and then of course loose components. Okay, danger of arcing, and of course a full failure within your systems. Okay, so what do they do? So what do these relays and circuit breakers do? Well, primarily they de-energize power. So now you can go back and work it. At home, you got circuit breakers on your panel at home. You know, one of the items that you trust, and again, that's why you have codes and inspections, is when I de-energize that breaker to my refrigerator, I can go replace the outlet. But what do you do before you touch that outlet? Anyways, you test it, right? Absolutely. Make sure that there is no visible current. Because maybe the homeowner before, he lost a circuit or wire, says, well, there's a wire there, I'll just jump it. That happens a lot. Okay, that's, again, safety, utmost importance. Okay, so every main protected device incorporates an overcurrent protected device. Again, I don't want to create a fire, or worse yet, I melt a wire inside a conduit, and it's deep in my attic, or it's deep in my basement. And then at that point, I'm at a point of no return. It's a replacement, costly, extremely costly. So the breaker protects my infrastructure, okay, that it's there for. A fuse is a one-time device. When it blows or fails, it's not like I can put the MacGyver, you know, the foil bubblegum wrapper and put it back in. No, it's not going to work that way. When it goes out, it goes out. But the question you got to ask yourself before you put another fuse in there is why? What caused it to fail in the first place? Could you imagine? A 10-amp fuse is one thing, but putting in a 60-amp fuse that's about that big around, you don't want that one to go off. You know, one, the noise is just enough to scare you. Okay, and a circuit breaker trips or opens when an overload or circuit. So those what I consider the reusable, recyclable. But even then, if there's an overload that trips or overload that trips your breaker, one of the maintenance requirements, if you will, reliability checks, is to find out what caused that overcurrent. And there's ways of checking that. You can put a dryness machine on your panels in that particular circuit that determines what level of load and at what time. So maybe somebody has a refrigerator that kicks on, you know, every evening at 6 o'clock nobody knew about. Well, you can see the spike running through. But the main objective in this particular one, maintenance, is to find out what caused the overload to cause that breaker to trip, and then go back and rectify it. A lot of buildings that you will build have modular furniture. They have built-in breaker systems, okay, within that. So part of that, any working in an office area sees an outlet, first thing they're going to come to, I can plug it in there. Well, with the modular system, you know, they're very limited in regards to power. Just very simple, you know, a few watts, okay, in regards to power consumption. It won't handle, in some cases, a copy machine. It won't handle a coffee pot. And believe it or not, some folks will bring in the George Foreman grill and they'll plug it into their cubicle. It's like, no, you can't do that, right? But again, going back and determining what is the overload, you probably see some, yeah. Okay. Okay. And again, this is just a little cutaway from a typical breaker, okay? So low voltage molded case. Typical, I didn't bring any with me. I think everybody's familiar with a breaker. Okay. Low voltage air breakers, typically anything greater than 600 volts. Okay. Oil breakers, typically for outdoor use, basically for temperature, especially in Arizona or places where they got high temperature or the elements in regards to where they're installed. Okay. Again, coordination studies and those particular ones is the level that they trip. So part of your commissioning for construction may be that. So when I trip a 110 volt breaker, I don't want to trip it at the 480 level at my main panel, or even worse yet, go back to my substation where it may be a 5 kVA transformer, I trip it there. So that's what it's intended for. Is if it's a 110 volt 10 amp breaker, that's the limitations. At 10 amps, it trips and stops at that point. It doesn't go back up to cycle. Okay. And panel schedules, as we talked before, and then load test. Okay. Periodic load tests on your equipment, on your gear, will determine what is the load in this particular one. You know, you'll be surprised. After a building has been installed and it's been under use, say for 10, 15 years, there's a lot of TIs, tenant improvements, that occur within this building. So, does every TI have a set of blueprints for power? You typically would want to, but in some cases, if you have an in-house electrical team, you know, in some cases, you know what, we'll just go ahead and splice off of this particular J-box. When you open up a J-box, then what do you see in it? A bunch of wire nuts and wires, right? So it's, hey, look at that. There's some, I can put one more wire in this wire nut. Okay. But again, what you haven't done is you haven't done a load test on that particular circuit. Okay. Another opportunity for failure, premature failure.
Bigger, companies would definitely have a set of prints and stuff.
Oh, yes. Definitely. And, you know, and those prints, though, are only as good as the as-builts. And even worse, it's only as good as the red lines.
Yeah, well.
Right?
Yeah, it just cost me $2,000 to go through our whole building and identify all the panels and the circuits because they were all wrong.
Yeah. But once it happens, you know, then it continues and it permeates throughout the rest of your infrastructure. So this is where we get into procedures and we get into protocols and policies. So whenever you're working with power, a couple things happen. And one, if it requires city approval, city's going to want to look at your blueprints. Okay, where do you plan to, one, obtain an extra circuit? I mean, if I got spare breakers in my panel, that's one thing. But if I don't, and I want to go ahead and use an existing circuit, and then that's when your reliability issues start to impact and increase. Okay, everybody familiar with this? Okay, does that require maintenance? What is it? It's just a GFI. You see those? Yeah, you know, you usually press this button once in a while, right? Just press it and see what happens. If your hairdryer's still working, we got a problem, right? Okay, so test it. Hairdryer should not work. Now you hit the reset, dryer works, hit it again, doesn't work, it works, okay? Hotel room, you ever test them in your hotel room? Come on, hotel, you trust everybody that works in a hotel, right? Okay. I mean, I guess if my life depended on it, test it. Okay, all right. All right. But again, what they do is what? Any code, GFCI, anything to do with liquids, waters, okay? Anything to do with electrocution, okay, what that danger is. So again, regular inspection, cleaning, testing. And typically you'll have a little sticker that says GFCI because you can also go down the line. You can install a GFCI, maybe put 2 or more outlets. So you put your GFCI, right, protected on that particular one. I'm telling you is that you hit that one and there's 3 other outlets throughout the house that just went out too. So again, it's part of your wiring schematics and diagrams. Okay. And transformers, I mentioned before, you're taking power from my higher voltage, okay, and you're reducing it down to the level of windings. So I may have, say I got 15 kVA and I got 5 kV requirements. So my transformers is what going to redistribute that power, and then I can reverse it. I can increase power. Okay, same way, same application, right? Notice what these are back here. Okay, yeah, those are cooling fans. Okay, then I'm going to have fans, and in fact, you'll see them back here. In fact, there's transformers behind this building. You ever notice what's around those transformers? Yeah, spikes and racks. Okay, but there's something else. Drains. Anybody notice anything else? Next time you walk by them, see if you see any oil. Now, I know maintenance has been all over. I got the mic on at ASU, okay? But whenever you see patches of oil underneath a transformer, typically that's going to be an indication. And they've probably already been checked, okay? But in those cases there, definitely is going to be some sort of signs, right, of a potential failure. So, again, dry or wet, different types of systems. In this case here, it's going to be dry because it has fans. But in some cases, though, they're going to be liquid-filled, okay? Oh, another item, again, accessibility to all sides, okay? And typically, codes are going to dictate as what's the clearances, okay, within your transformers as well as your connections, okay? Motor control centers, typically you'll want them all basically located in a single source, so you have your power coming in, all your distributions in a single, okay, what I would consider motor control center. So very easily you can turn pumps off, chillers off, air handlers, cooling towers, and so on. Very convenient. It's all basically contained within typically one wall, okay? But on these particular ones here, these sections, different levels of voltages. You could have 208, 480. But every one of these is going to have a light bulb, believe it or not. Red for off, green for on, right? Do the light bulbs burn out? So when it's on, and you know it's on, there's no green light bulb, that's what? A clue. Right? So part of the maintenance program is first go through all the ones that are energized. There's a green light bulb letting me know it's an energized circuit. If it's off, I'm going to have a red light. Okay, so again, part of the routine maintenance requirements. Okay, these contactors allow the motor to be controlled remotely through sensors, manual controls. And in our case, we were talking about variable frequency drives, or VFDs, okay, where you can monitor remotely through an EMS, or energy management system. So these are very convenient because now you can tie the sensors in one remote, okay, what I would consider contiguous location. Okay. Switchgear, rolling up to the next level. Larger buildings often have their own protected devices, okay, with some sort of secondary feeder protection. These are going to be considered switchgear. So fuses, circuit breakers, okay, electrical live one is completely enclosed from within a metal structure. Reason for that metal structure is for protection. Okay. I don't have pictures. I want to bring pictures. Sometimes when SRP loses a switch, it's enough energy inside that cabinet to blow the doors off of that. And if you're standing next to it, that's coming. They usually got the old tape. Okay, those can be hazardous. Okay, but you figure, well, what's energy going to do? It's just going to like arc and then go out. It's not necessarily. That's an energy form. Okay, so again, that's why they have the metal enclosures contain everything that you got. If I have any type, okay, of explosion, not only that, but you also get your liquids in some cases, right, and also metals. Okay, that might also be a danger. But you want to contain everything within that metal cabinet. So if a door doesn't latch properly, believe it or not, that's maintenance. That should be written on the maintenance report. Make sure that it is latching properly and locked. Okay. Visual inspection ports. Remember the glasses we were looking through? Okay. Typically 1-inch glass, again, as a protection device. Okay. Service entry equipment. You're going to be very familiar with this as part of building construction. Okay. So basically, this is the service interest coming off the utility side. And with that, it's going to be in a certain level. Large buildings typically is going to be near the central plant, but typically it's going to be somewhere within the building where the service is not only accessible, but the conduit that's supporting that as well, okay, that particular service equipment. A main protected device is a means of disconnecting an entire building from the electrical service. So in the event of an emergency, typically fire department access. So I need to shut down the power for my building that's flooding, okay, to minimize not only electrocution to the occupants, but the first responders. The first thing they'll do is disengage the power. As an owner, it's like, oh, please don't do that. But for the sake of safety and not to jeopardize lives, that's the first item that they're going to go. This completely quiets the entire building. It brings it dark. So instead of going to each panel, you would go to the service line. The switch must be located near where the service interest conductors enter the building. So when you're looking at your plot plan or your site plan, you can determine where is it coming. It's coming off the street, off an alley, okay, off an adjacent building. and determine where's the service interest going to be. Then after it's installed, items such as accessibility to the service entrance, okay, tagging, identification, nameplate information is going to be critical as well. Okay. Then of course relays, again, another protective device, right? They detect any type of low or high current. First thing to do is protect that piece of equipment or that gear, okay, what they're intended for. So again, regular things is inspect for deterioration and check for operations. So you trip the relay. Does it actually work? Does it disengage? Sensors, checking sensors out. All part of the maintenance program. So new building construction, part of your commissioning is checking relays and activating sensors, making sure that they do perform as what they're designed to do.